Good afternoon, distinguished guests, participants. I wanted to start my presentation with good morning, but we are here now in good afternoon. So my presentation was scheduled at 11:50 earlier. So when we talk about innovation, I think digital transformation has become key to innovation today. We are at the cusp of fourth industrial revolution. But if you remember how first industrial revolution started, what was the key thing for first industrial revolution? That was steam engine. And the biggest, most successful use case of the steam engine was railways, transportation sector. And now at the cusp of fourth industrial revolution, which is led by AI, ML, digitalization, I think railway sector or metro cannot be left behind. So my topic of presentation today is digitalization, digital transformation in Delhi Metro. I'll be discussing some of the use cases. Can you put my slides, please? So I'll be briefly talking about Delhi Metro. I'm sure most of you are aware about Delhi Metro. And then I'll be talking about what are the key enabling technologies for digital transformation, uh, and then some of the use cases. So Delhi Metro, as you are aware, we are carrying 60 lakh passenger journeys a day. We have a network of 393 kilometers, 288 stations, more than 12 lines, more than 20 depots. So we have huge network, and we are having good ridership. And we are the only metro system in the country which is in operational profit. Okay, till the time presentation is loaded, I think I can work with my mobile. So the key enabling technologies which is driving digital transformation today are internet, IoT, cloud computing, 5G technology, big data, AI, and today we are in generative AI. Okay, thank you. So moving quickly to digital transformation. So these are the key enabling technologies. So I like to tell, you know all about internet, IoT, cloud computing, but I like to say something about generative AI and some of the use cases like Chat GPT, like how passengers are interacting with you. So customer interface, we can have number of use cases on generative AI, APIs, application programming interface. So we have been developing lots of IT systems. Like this has whole bouquet. I should say it has more than garden of IT systems. But how to integrate these systems? So API is one of the transformation enabler, which brings all the IT systems together, can exchange data. These are some of the areas for digitalization. Customer service, how you are interacting with your customers, how you are selling your tickets, uh, uh, CRMs, traffic management, that is your signaling system or a number of applications which are managing traffic, asset management, and maintenance, both predictive maintenance, condition-based maintenance, digital platforms like railways has number of digital platforms, FOIS, TOA, for metro systems also, crew management system, timetabling system, network planning. Then business processes like how to manage your business. We have ERP systems in railways. We have iPass. We have HRMS. So how you manage your own business. Then digitally integrated transport service, which has become very important these days because it's not only one transportation system which caters the need. It is multiple transportation system and which they need to be integrated. Then adoption of data analytics for the purpose of demand forecasting, condition monitoring, predictive maintenance, and of course, most important, data security. When data has become gold, it is theft prone. So you need to ensure that your data is safe. I'll be talking about some of the use cases that DMRC is working on. First is digital transformation of ticketing. So we are working on three principles when we talk about ticketing. Tickets should be available through multiple media, that is card, token, QR code, NCMC card. It should be available through multiple channels, like mobile phone, WhatsApp, Paytm, and multiple modes of payment should be available. So like in multiple modes, media, we have smart card, we have NCMC, we have QR ticket. Green ones we already have. And we are also working on account-based ticketing, where you can use your credit card, debit card directly, and near field communication, where mobile phone becomes your ticket. In multiple channels, we already have our DMRC mobile app. Then our QR ticket is available on WhatsApp, Paytm, Tom, TVM, and we are also working on ticketing through IRCTC. So we have a concept of integrated ticketing with IRCTC. When you will be booking your IRCTC ticket, railway reservation ticket, you will get an option to book metro ticket also if origin or destination is in Delhi. So then PhonePe, you will have soon our ticket. One Delhi app is the app which serves, which is for the buses in Delhi. So that is operated by DTC. So we'll also have metro ticket on One Delhi app. Then another app, Tumok, which is also very popular in the transportation industry. We are planning to have integrated ticketing on Tumok and then Amazon Pay. So these are some of the channels that we are exploring. Then multiple modes of payment. We already have payment through UPI, credit card, debit card, net banking, and cash. Next is predictive maintenance. We are working on predictive maintenance for health, for signaling system, for bearing system, wheel profile management, and super SCADA, that is integrated super SCADA. So RHMS is for monitoring the critical parameters of point of machine. Sensors have been connected with signaling gears, and they monitors how much current is withdrawn when a gear moves, how much current is withdrawn, and whether it is in the permissible limit. If too much current is withdrawn, then there may be some friction and it needs maintenance. So footprint is generated for each gear using machine learning algorithm. So this kind of footprint is generated, and we can see that whether this particular gear needs any maintenance. These are the devices that we have installed. Sensors on the point machine and signaling gears. Advantages like condition monitoring, predictive maintenance, reduced physical movement of the staff. Next is bearing health monitoring system. It is for the bearing which is attached to the traction motor. So typically this system has been provided by OEM SKF. Typically life of a wheel is 20 years, but this gearing case requires overhauling after 8 years. So we have installed IoT sensors on the gear case to monitor vibration and temperature and to predict the failures. So this is the gear case, and on both sides are the bearings on the gear case. This kind of IoT devices have been installed, which monitors vibration and the temperature. So this is one of the case study that this sensor was installed on one of the train set, and it recorded that on 1st of August 2023 that there is a significant failure, significant deterioration in the condition of the bearing. And when this bearing was opened, it was found that there were marks of the wear and tear, and that was replaced in time before this failure could have occurred. Yeah, these are some of the photographs. Then we have automatic wheel profile management system. This has been installed in one of the depot. When a train enters into the depot, it monitors its flange width, flange thickness, root thickness, and wheel diameter, and it generates real-time alerts if they are not within the limit. So this kind of system is there. There are RFIDs and this laser scanning module. So like RFID 1 reads which train set it is, and then RFID 2 tells the system to open the laser, and then these measurements are taken and sent to the central server. And if there is something missing or wrong, that alert is generated. Then we have Super SCADA, that is integrated Super SCADA, which is to integrate and monitor the health of different systems. So it uses IoT devices. It has been indigenously developed. So it has 3 modules: work management module, failure management, and asset management. So when a system is not working, it generates the work schedule. It tells the person who is responsible for the maintenance that this particular asset is not working, and work order is issued automatically. So this is the single dashboard. It covers AFC system, lift, escalator, Calipari system, hot axle system of the rolling stock. Sorry, accelerator is spelling is wrong. But the point is that it not only generates alarm, it also helps in condition monitoring through AI ML algorithm. So like this lower graph, it has predicted that this bank note system is going to be faulty, and it has generated some prediction and which actually matched with the actual system. 85, there was a 80% plus accuracy in the prediction. So these are again. Then we are also exploring big data based feeder bus routing system. So how do we typically decide a route of a feeder bus? We go, we do some survey that so many passengers are traveling from here to here, and then we decide the route. So that is basically based on some physical survey. But today we have lots of mobile data. Every person is using mobile, and it generates the footprint of the person, that how and when he is moving. So this mobile data has been used to predict, to find out the route for feeder bus. So this case study is for the Chhatarpur station. The mobile data was used to first identify the catchment area, catchment, like who and when the people are traveling to this station. So catchment area was first defined, and then the routing was done. So this catchment area was divided into 500 meter by 500 meter grids. 7 days data was used, which was 3 million trips. So that's why it is, I'm calling it big data, because huge data set was used. And then AI algorithm was used, that is optimization engine was used. This is an NP hard problem. Traveling salesman algorithm was used to determine the routes, and it gave 6 routes, 3 routes for the buses and 3 for the e-rickshaw. And we could also give some constraint like this road width should be at least 9 meter, total journey time should be within 30 minutes. So these kind of constraints can be built into the system, and with these constraints, it suggested 6 routes, and these are the routes. So this we are planning to use at other metro stations also, to identify optimized route for the feeder buses. And this can also be used for demand prediction for the metro system, like where metro corridor should be there. So that demand prediction today is again done based on 4-step model, but this is advanced model which gives you huge amount of data and reliable data. So some of the use cases that are in pipeline: timetabling optimization, we are working. That is how to minimize, how to use our rolling stock more productively. Crew scheduling optimization, we are working to improve the productivity of crew. OHE monitoring system using thermal camera, again as a predictive maintenance solution. Operation control tower, to create an integrated dashboard for all our lines to see the ridership, assets, revenue. Predictive maintenance for lift and escalator. Data analytics using TCMS data of rolling stock, that is train control management system data of the rolling stock, will be used for predictive maintenance of the rolling stock. Then image recognition and sensor to monitor track health. We are planning to have cameras on our trains which can monitor the health of the track, and it can generate alarms. And then AI based chatbot, we are working for the passenger segment. I'd like to end my presentation with this quote by Natarajan Chandrasekhar, the CEO and MD, Tata Consultancy Services. Going digitally is no longer an option, it is the default. So we have to go for it if we want to remain viable and sustainable in coming world. Thank you very much.